Okay, so this is for worksheet 12.5, part 2. So this is actually how to do the new stuff. So starting off here, what we're going to do is kind of go back to geometry. I know it's been a long time since you have geometry, but a couple things that you talked about in geometry, and hopefully you talked about, is like planes and lines. But usually you just say, okay, a line will intersect a plane in a single point. And that's all you kind of have to remember is wrap your head around it. Well, what we're going to do today is actually find what that point is that you talked about in geometry, 4 years ago maybe, just yesterday. So let's say if you have a plane, and let's say you have a line, okay, so this equation RT in this plane here, AX plus BY plus CZ equals D. Well, a line will intersect a plane in a common point, and that's all you had to do in geometry back then. Okay, so the question is, where is that location here? So let's look at what you have. So there's no new math. It's just a matter of, think of it like a puzzle. Lay down all your pieces, take a see what you need, and do the math. Okay, so let me give you the pieces here. So you have equation of the line. So this is your RT. So you have, read my own notes. Oops. The point here of 1, 2, 1. And you have t, and you have -2, 0, 1. Like so. So now the equation of the plane here, that would be 3x minus 9y plus 2z equals 7. So now, first off, let's look at the equation of the line. Now, it is nice to write it like this because it just condenses. But let's break it down and look at the components of this. So for my RT, my x component is 1 minus 2t. My y component is 2 plus 0t. And my z component is 1 plus t. Well, this is also your x component. This is also your y component. And that's your z component. So that would mean that if we do a simple substitution here, all we have is now converted in terms of x, y, z, and t. We have now nothing but t. So what we can do is actually find the time that it will intersect. And once we have the time, then we get the location. So let's substitute in here. So I have 3, and that would be 1 minus 2t, minus 9, and that would be just 2, plus 2, and you have 1 plus t equals 7. All right, so let's try to do the algebra here. So you have 3 minus 6t minus 18 plus 2 plus 2t equals 7. My 2 times, and we got -4t. So we have 5 minus 13 equals 7. So we have -4t equals 20, and the time is -5 seconds ago, -5 minutes ago, all that. But remember, we want to look for the location also. So come back here, and this is plug in for our x component, y component. So my x component would be 1 plus 10. So my x component location is 11. My y component is just going to be 2 all the time. And my z, 1 minus 5, so my z component is -4. So here's my time. My location would be 11, 2, -4. So notice it's just a matter of looking at what you have, and this is all you're going to be doing here. You're going to do dot, crosses, unit vectors, and that's pretty much it. Just doing different combinations of these. Okay, like here's simple substitution, but you have to understand what you have to move on or answer the question. All right, so let's look at another one here. Okay, so let's different combination here. Say we have a line through these 2 points, 1, 0, 1, and 4, -2, 2, and they intersect the plane. I have x plus y plus z equals 6. Okay, well, first thing you gotta do is find the equation. Okay, so you gotta have the slope of the line. So, and I'm assuming we'll start with this point here. So it'll be 4 minus 1, -2 minus 0, 2 minus 1. So you have 3, -2, 1. Okay, so that's the slope of RT. So RT, and I said we start with that one here, 1, 0, 1, plus T, and 3, -2, 1. All right, so now let's break down the components of the line. So RT, x component, 1 plus 3t. My y component is 0 plus -2t. And my z component, 1 plus t. And take a look at what you have. Those are the same at some point in time. So again, if I do a substitution here, I have 1 plus 3t. My y component is this -2t. My z component, 1 plus t, equals 6. So let's see if we can do the math here. Okay, 3t, 1, 2t. My numbers, 1 and 1 plus 2 equals 6. So 2t equals 4 and t equals 2. And there's my time. All right, and now let's go ahead, and since we got our time, my point of location at that time, and so it's coming back to here. So my x component, that's 2, 6, 7. My y component is looks like -4, and my z component is 3. So the location at that time would be 7, -4, and 3. Okay. All right. Let's go to the next scenario here. Okay. So, looking for another question you had in geometry was 2 planes that intersect form a what? Okay, so I don't know if I can draw this or not. This is where it helps be in a classroom and not me drawing. So there's the one plane, and let's say we have another plane here. Okay, so what's in common between these two? Well, what would be common would be this right here. So 2 planes intersect to form, so 2 planes intersect to form a line. And that's basically all you had to do in geometry a couple years ago. But now we're going to be looking for what is that line. Okay. All right. So let's start off by breaking down one plane first. Okay, something that happened in Algebra 2, and who knows, I kind of taking this out of Algebra 2 for some reason, that finding traces of a plane. Now, one reason I think a lot of people didn't realize what was happening here, it's kind of a building block for what we're doing right now. So let's do the traces. Now this is like finding the x and y intercepts in standard form of a single line. So I'm going to start off by, first off, let's say let z equals 0. Well, if z is 0, then I have 2x plus 4y equals 12. And if you remember, when you have a standard form, you get the x and y intercept. So if x is 0, y would be 3. Or if y is 0, x would be 6, provided that z is 0. So in Algebra 1 and 2, you just did like this. So what we're doing is finding a trace between two in the plane here. So we're going to do that one, and well, anyway, let's go ahead and do the math. So now let's say x equals 0. That would mean that I have 4y plus 3z equals 12. So if I have y equals 0, z would be 4, and z is 0, y would be 3. And I think that should be enough to get the traces going here. Okay, so let's draw this out. So here's my x, z, and y. Okay, so let's come back where z is 0. That would mean y would be 3. So I'm doing this point here. So 1, 2, 3. And now let's do this one here, 6, 0. So 1, 2, 3, 4, 5, 6. So this would be the trace for 2x plus 4y equals 12. Okay. Now let's do the next one here. Together. So first off, this point here, 4. 1, 2, 3, 4. And notice you have 3, 0. So this would be 4y plus 3z equals 12, which now leaves me this one already done. And this would be 2x plus 3z equals 12. And that's about as far as we ever did in Algebra 2. Let's find the traces of that. But what does that help us? Well, what it does is if we use a trace, let's say this one here, of this plane, and the same trace of the other plane, what we have is two equations, two unknowns, and what it'll do is give us a single point on that line. So let's come back here. So what we're going to do here is using two traces, and we're going to find a common point. And remember what you have to write equation of RT. You need a point and the slope. So by using two traces, you get a single point. And we'll talk about the slope after we get the point. Okay, so let's do the point first. Okay, all right. So here's my two planes. Okay, so I have x plus y plus z equals 1. And my second plane, I have x minus 2y plus 3z equals 1. Okay, so it doesn't matter which traces you use. So I'm going to say, let's set z equals 0. So that would mean the trace of x plus y equals 1 and x minus 2y equals 1. Okay. Okay, so what I got now is two equations, two unknowns. So let's go ahead and take this one, plug it over here, and let's change the signs. So I'll multiply everything by -1. By doing that, so negative x plus 2y equals -1. 3y equals 0, so y is 0. And if y is 0, so x would be 1. Okay, so what we have now, we have a point on the line. So my point on my line is 1, 0, 0. Not too bad. Yeah. Okay. And remember also too, if they get complex values, you have your calculator where you can plug two equations in, find where they intersect, but hopefully you don't need to do that. Hopefully you can do it by hand. All right, so now here's the part of writing an equation for RT. So you need a point, which we got, but the second thing is the slope. Okay, so let's think about what planes give us. Okay, so if I have a plane here and another plane that's going to intersect it, oops, I'm not drawing these out right. I should have went back to my other drawing here. So, butchered that one, didn't I? All right, so this line here, okay? Well, the equation of planes is defined by the orthogonal vector. So this has an orthogonal vector, the one in the green, and then the purple has an orthogonal vector. So these orthogonal vectors will intersect perpendicularly. So these are the normal vectors. But we're looking for the equation of the line, the slope here. But if we find the cross product of these two values here, so if we do the cross product of these two norms, this slope here will be the same slope over here. So these would have the same slope for R of t. So all we have to do is do the cross products of our slopes of our planes. And hopefully, like I said, I wish I was in the classroom so I could show you that much more easier. But realize we're going to find the cross product of the norms, and those cross products, we have the same slope of the line where they intersect. All right. So coming back to the plane there. So one plane had a slope of 1, 1, 1. The other plane had a slope of 1, -2, 3. So if we do the cross product of that, we would then have the slope of RT. Okay, so I, J, K, 1, 1, 1. It doesn't matter how you put this in order. Okay, remember this is going to be a slope this way or slope this way. Our D value will take care of the direction there. Okay, so let's go ahead and finish this out. So my I component, Okay, what's that? 3 plus 2 minus my j component. 3 minus 1, my k component. Negative 2 minus 1. So you have 5 I hat minus 2 j hat minus 3 k hat. So the slope of my RT is 5, negative 2, and negative 3. And coming back to the point here, hopefully we use the same, right? And my point was it 1, 0, 0, 0? So my point was 1, 0, 0. So therefore, my equation RT is 5, negative 2, negative 3t plus 1, 0, 0. Okay? And again, I could break it down by components, but just choosing the fast way of doing that. And that's it. So remember, just try to wrap your head around what you have. And remember, I talked about, the norms of a plane and equation of the line. So hopefully that makes sense. So let's do another example here. Okay, so here's my two planes. So I have 2x. Oops. No, that is 2x plus 5z equals negative 3. And let's say x minus 3y plus z and negative 2. Okay. So that would mean 0y is that. Okay. So therefore, let's find the point first. So now if y is already 0, let's just keep it that way. And therefore we'd have, that trace be 2x plus 5z equals negative 3. And if y is 0, you have x plus z equals negative 2. Okay, so dumping this in here, I'm going to go ahead and multiply everything by negative 2. So I have negative 2x minus 2z equals 4. Cancels out. 3z equals 1. Z is 1/3. Okay. And let's come back here. So x plus 1/3 equals negative 2. X would be negative 2 and 1/3, or negative 6, negative 7/3. So my point. X negative 7/3, 0, and 1/3. Okay, so there's the point on RT. At least one point. Keep in mind there are millions of these, but we just found one that came out easy. Okay, so now we got to find the slope. So again, if you look at, here's the norm of one plane, then the norm of another plane. So if we find the norm of the norm, like that, find the normal of the normal, that perpendicular to that, perpendicular to that, this would be the slope of RT. Okay, so let's do the cross product. So therefore, if I have slope on my 1 be 2, 0, 5, cross it with 1, negative 3, 1. Okay, moving up here. So I hat, j hat, k hat. So we have 2, 0, 5, 1, negative 3, 1. So my I hat would be 0 plus 15. Minus j hat, 2 minus 5. K hat, negative 6 minus 0. You have 15 I hat plus 3 j hat minus 6 k hat. Okay, and therefore there's the slope for RT. My slope is 15, 3, -6. So let's put T there. Let's come back from my point. My point is -7/3, 0, and 1/3. And there's my equation of the line. So, okay. Couple things to point out before I forget. If you go through and find your traces, okay, so we're talking about the traces. If you go through and solve, and let's say everything cancels out and you get 0 equals 0, that would mean that the line, they are one of the same. Okay, if you get something like, say, 0 equals 5, that means they don't intersect. Okay, all right. So a couple things to talk about on the traces there in terms of solving that could happen. So just think about back in Algebra 1 and Algebra 2 days of all solutions and no solutions of what that would happen when you're solving with your traces. Okay. All right, one last thing here. So if two planes intersect, they got to intersect at an angle. So keep in mind, how do you find angles between lines and planes cannot change. Okay. So the same equation that we've been using, a dot product, magnitude of A, B cosine of theta, and A dot B. And you're saying, well, that works for a line, but how does that work for a plane? Well, we're talking about the planes form an angle, but the norms, again, come back here, the norms of the plane 1, plane 2 would also have to intersect at the same angle as the planes do. So we're not going to find the angle between the two planes. We're going to find the angle between the two norms, and they are both the same. So therefore, if I have, let's say, these two planes, let's say x plus y plus z equals 1, and x minus 2y plus 3z equals 1. So the norm of 1 would be 1, 1, 1. The norm of the second one, 1, -2, 3. Okay, so if we find the angle these two lines form, this theta here, that would mean that that would be the same angle that the planes are intersecting. Okay, so let's just review on how to do that. So first, the magnitude of A. Excuse me. So square root of 1 plus 1 plus 1, we're at 3. Magnitude of the other one, B. We're at 1 plus 4 plus 9. We're at 14. So you have root 3 times root 14 times cosine of theta. And then we're going to dot 1, 1, 1, dot 1, -2, 3. So there you have 1 minus 2 plus 3. Okay. And we're going to divide that by square root of 3 and square root of 14. That's cosine of theta. And I do believe it turns out to be about 72 degrees, somewhere in there, finishing that off. So again, we are finding the angle between the two norms, but those norms have the same angle as the planes. So again, like I said, nothing new, just wrapping your head around what you